f of x is equal to 25 over 3 plus 2x squared multiplied by 1 minus x, and the modulus of x is less than 1. Part A, express f of x as the sum of partial fractions. So let's take our f of x function and split it up into 3 fractions. We'll have a over 3 plus 2x plus b over 3 plus 2x squared plus c over 1 minus x. We'll get a common denominator. So for the first fraction, we've already got a 3 plus 2x. So we've already got one of those. So we just need to multiply by another 3 minus 2x. 3 plus 2x. And we also need to multiply by a 1 minus x. Next fraction, the b term, we've already got the 3 plus 2x squared, so all we need to multiply here is 1 minus x. And then the third fraction, the c fraction, we've got the 1 minus x, so we need the 3 plus 2x squared. Now we have the same denominator. That must mean that the numerators are going to be the same. So we can rewrite this as 25 equals a times 3 plus 2x times 1 minus x plus b times 1 minus x plus c times 3 plus 2x squared. Plus c times 3 plus 2x squared. So let's work out what a, b and c are needed to make this true. So I'm going to start off by letting x equal 1, because that's going to make these two terms become 0. And that will allow me to work out the c term easily. So if x is 1, well, the left-hand side is just always 25. The right-hand side, then I'll get c times the 3 plus 2 times 1. So 3 plus 2 is 5. 5 squared is 25. So 25 equals c times 25, so c is 1. So we know that c is 1. So let's put that 1 in those two places. Right, the next substitution I'm going to pick is going to be that x is equal to minus 3 over 2. The reason that I've picked that is because that's going to make this term be 0 and this term be 0, and allow me to work out the b term. So left-hand side will just be 25. Like I say, the a term will be 0, the c term will be 0, and I'll just get b times 1 minus 3 over 2. So 1 plus 3 over 2 is 5 over 2. So times both sides by 2. And I find that 5b equals 50. Therefore, b equals 10. So now we know b is 10. We can replace that here and here. Finally, let's work out the a constant. Now, there's no substitution I can do for this. So let's compare coefficients of x squared. So compare coefficients of x squared. On the left-hand side, we've just got 25. There's no x squareds there at all, so let's put a 0. On the right-hand side, if I was to expand this out, then from the first bracket, I've got this 2x times minus x. So that would give me a minus 2x squared, which when multiplied by the a, so I get minus 2a x squareds. Then looking at the b term here, we've got there's no x squared term at all there, so we can ignore that completely. Then looking at the term over here, expanding that out, I'd have 2x squared. So 2x times 2x is 4x squared multiplied by 1. So that gives me a 4x squared. So now I can see that 2a would have to equal 4. So a is 2. And I can then replace that here and here. And there we go. Let me just rub my working out. Let's erase the working out, and then we've finished part A of the question. So my final answer for part A, we are saying that splitting this up into partial fractions, again, all of this red was just my working out, so we don't need that. And this was how I wrote my answer. Okay, moving on to part B. Hence, find the integral of f of x. So we want to integrate 2 over 3 plus 2x plus, now for the second term here, I'm going to rewrite that with a negative power, because that's the way we integrate something over x squared. So I'm going to rewrite that as 10 times 3 plus 2x to the power 2. The third term I'll leave as a fraction because the denominator is linear. So we're going to integrate that with a logarithm. Right, so let's integrate each term then. So the first term, we will get 2 lots of ln 3 plus 2x. But by the reverse chain rule, we're going to have to divide by 2. So that's actually going to simplify just to be a single 1 ln x, 1 ln 3 plus 2x. Next, that second term, I missed off the minus there when I was writing it down. The 2 here should go to the top and be a minus 2 power. So we can add 1 to that power. So the new power is going to be minus 1. We'll divide by the new power. So 10 divided by minus 1 would be minus 10. So that's going to simplify to be a minus 10. But by the reverse chain rule, we need to divide by 2. So dividing by 2, the 10 divided by the 2 is 5. And then the third term, we've got 1 over, so that's going to integrate to be a logarithm. But by the reverse chain rule, we have to divide by minus 1, because that's the derivative of the new function, of the inside function. So dividing that by minus 1 will make this a minus ln 1 minus x. Not forgetting the plus c for the constant of integration. And there we go. It's not told me how I need to leave my answer, so I don't need to worry about simplifying any of the logarithms there. I can just leave my answer like that. Right, moving on for part C. Find the series expansion of f of x in ascending powers of x up to and including the term in x squared, giving each term as a simplified fraction. So we are going to have to expand each one of these terms, each one of these expansions using the binomial theorem, and then collect up the like terms. Let's remind ourselves of the binomial theorem. It is this. This is what you're given in the formula booklet. So if we want to use this formula, we need to rewrite each of our expansions, or each of our terms, to expand as 1 plus x to the power n. So let's do this. Let's start off with the 2 over 3 plus 2x. So we can rewrite this as 2 times 3 plus 2x to the power minus 1. But I'm not allowed to have a 3 here at the front because that needs to be a 1. So I need to factorise that 3 outside. Let's leave the 2 there for a minute. If I factorise the 3 outside, I'll get a 3 to the power minus 1 because the 3 is still to that power. The 3 will be a 1 now, and the 2/3 divided by the 2x divided by 3 is 2/3 x. The 3 to the power minus 1 is the same thing as 1 over 3, which when you multiply it by the 2 will be 2/3. Right, let's use the binomial theorem. So 2 over 3. Right, let's expand each of these terms then. We'll have a 1. We'll have the n, which is minus 1, times the x, which in this case is 2x over 3. The next term will be n times n minus 1 over 1 times 2 times 2x over 3 squared. And I don't need to include any more terms because have a look here, I only need to go up to x squared, so that's enough. Right, we've got the 2/3. Right, let's simplify each of these terms then. We've got the minus 1 times the 2x over 3. So that's minus 2/3 x. Then we have the minus 1 times the minus 2, so that's a plus 2, divided by 2, so that's just 1. And then we have the 2x over 3 squared, so 2x over 3 times 2x over 3 is 4x squared over 9. Now multiplying each of those terms by 2/3. 2/3 times 1 is 2/3. 2/3 times 2x over 3 is 4x over 9. And the 2/3 times the 4x squared over 9 is 8x squared over 27. So we have just shown that this is the same, well, the first 3 terms of the expansion of that are this. So I can replace this with those 3 terms. Right, let's now move on to the second expansion. So exactly the same thing. We need to rewrite it so it's in the form where we can use the binomial expansion formula. So I want to move that 3 plus 2x squared up to being on the numerator. So I would have 10 lots of the 3 plus 2x to the power minus 2. And just like before, I'm going to have to factorise out that 3 because it needs to be a 1. So taking the 3 out would be 3 to the power minus 2. And on the inside here, we've got the 1 plus 2x over 3 to the power minus 2. 3 to the power minus 2, that's 1 over 9. And 10 times 1 over 9 is 10 over 9. Right, let's now expand this out. This first term is 1. Second term is going to be n, which now is minus 2, times x, which is 2x over 3. Then we have n times n minus 1 over 2 times 1 times 2x over 3 squared. Let's simplify each of these terms. So we've got the 1 at the front, then we've got the minus 2 times 2x over 3. So that's going to be minus 4x over 3. Then we have minus 2 times minus 3. So that's plus 6. Divided by 2. So that's 3. So that's just 3 there. Then we have the 2x over 3 all squared, which would be 4x squared over 9. And the 3 times the 4x squared over 9 would give me 4x squared over 3. Now let's multiply each term there by 10 over 9. So 10 over 9 times 1 is 10 over 9. 10 over 9 times 4 thirds will be 40 over 27, which we could simplify down a little bit, but we can do that in a minute. Then the 10 over 9 times 4x squared over 3. So again, that's going to be a 40 over 27 x squared. So we have just shown that the first 3 terms of that is this. So let's write that here. What was a 27 on the denominator there, not a 9, not a 29. Right, and the last expansion. We need to do this one more time for the 1 over 1 minus x. So, again, we need to rewrite it at the beginning, so we have a 1 plus x to the power n. So we're going to rewrite this so that it looks like 1 minus x to the power of minus 1. You'll be glad to know there's no factorising at all needed here. We can just get straight into it because we've already got it a 1 at the front. So that saves us the job. So we can just write 1 plus n times x plus n times n minus 1 over 2 times 1 times x squared. Simplifying, so we've got the 1, we've then got the minus 1 times the minus x, which gives a plus x. We've then got the minus 1 times the minus 2, which is a plus 2, divided by 2, which is 1. 1 times minus x squared, so 1 times x squared will just give me an x squared. And so that is my third term. And all we need to do now is collect up the like terms. So let's just pick out what they are. We've got 2/3 plus 10 over 9 plus 1. which is going to give us 25 over 9. We have got the minus 4x over 9 minus 40x over 27 plus x, which gives minus 25x over 27. And then finally adding up the x squared terms, so adding up these three terms, we will get 25 over 9x squared. And that's our answer.